Okay. Okay. Good afternoon. Right. So let's continue with our second session on computer network. So last time we discussed introduction to computer network. Basically, we discussed what is a computer network, why do we need computer networks, what are the small computer network types like body area network to internet. And also we discussed some basic terminology behind uh, computer network. And also we discussed the 7-layer OSI architecture. So we covered a lot of things last week, last session. So then we even started the layer 1 in OSI architecture, the physical layer. So today we want to finish the layer 1. So remember, we don't uh, go into details all 7 layers, but we are more interested in layer 1, layer 2, layer 3, then little bit of layer 4, and then layer 7. So today we want to possibly finish layer 1, physical layer. Remember physical layer, logical link layer, network layer, transport layer, then session and so on. But finally we are interested in application layer. Still we are in the physical layer. So remember, we discussed that every layer has a specific objective or set of objectives. Then some features related to that layer. So physical layer is concerned about how physically your computing devices are connected. Okay, connected. So in this layer, we don't have any addressing schema, and we don't have any software related concepts like protocols or soft concepts like protocols. It's more hardware, hard concepts, and little bit more like electronic, because this is physical. And you know that electronic is part of the physics. So therefore, obviously, physical layer is more really physics, engineering related things. Okay, right. So we start discussing the components of communication. So between two components, we need a sender and receiver. Then physical communication media, wired or wireless. And then we need a protocol minimum, so that the receiver can understand what the sender says. And remember, we send data, we say messages as set of signals. So that signal carry the message or data. Okay. So that understanding you must have. And when it comes to more than one parties are involved, there's another concept comes to the picture, that is addressing, and also possibly something like routing, switching, directing the traffic to the correct destination. Okay. Right. So therefore, first we start discussing signals and waves, because our data, the sender's data, set of ones and zeros, of course, ultimately it must be in the receiver side, but we represent this as a signal, and that signal is sent. That signal is interpreted by the receiver as your data. So that I hope now you have that big picture. And if you have any doubt about it, if you have anything that you need more clarification about it, because you can't proceed, go forward with doubts. Okay, so you can go forward when you have understand the previous topics. Right. So therefore, we start discussing about signals. Of course, waves can represent a signal. Okay. So we discussed that there are two types of waves. That is analog waves and digital or discrete waves. So why we are interested in waves? Because waves we can send from one place to the other. Okay. Analog signal or analog waves and digital waves. So analog waves are continuous waves. Right? It continuously, gradually change the energy level. But digital signals, all of a sudden, the energy level goes from one level to the other and come back. Okay. So there is a difference between analog wave and analog signal and digital signal, or analog wave and digital wave. Okay. And analog signals are more natural. We can readily find in nature. For example, if I talk, when I talk, someone nearby can hear me. So the result is sound wave is generated by my mouth, and that sound wave, which is analog signal, transmit to the listener's ear, and ear can interpret it, understand that wave. And if you take something like C, you can see analog waves, C waves. C waves are analog waves. Even if you take something like wind, it's sort of analog wave, but it's more physical, but it's also analog. So digital signal is very rare to find in nature. Of course, we can create artificially. We can create, but in nature doesn't support it much. Okay. But remember, we like digital signals because digital signals are more closer to the digital data. Because you can clearly see this is, I can say this is maybe 100 111 0 1 1 0 0 1 1 1 1, maybe 0 0 0 1 and so. So you can see that digital or discrete signals are more closer to digital data. That is what we computer does. Computer store and process digital data. So therefore, we like digital signals, but unfortunately, uh, for long distance, transmitting digital signal is not very practical. So what practically possible for long distance is analog wave. So that is why we need to convert digital signal into analog signals and transmit long distance and so on. So likewise, you must gradually understand the concept, the reality. Remember, science subject, technology subject, we look at the reality. We look at what we do, what our engineers have developed, our scientists have developed, and practical use. Of course, those are sometimes very challenging to understand, difficult, because as humans, we try to overcome these difficulties and move our human civilization forward. So that is the difference between humans and other animals. Okay. And that is why you want to learn this tech subject, because you want to be part of that driving force one day. Okay, right. Anyway, we discussed these things still, right? So we did these things, but this is very important area. Okay. Right. So remember digital signal, that is discrete. Discrete means all of a sudden the state change. All of a sudden state change. Okay. Can be either binary or more than two state. So binary means two state discrete signal or two state digital signal. So that means it has all of a sudden changed the state, but only between two possible states. What we can call it one state and zero state. But theoretically, we can think of multi-state digital signals, maybe 3 state, 4 state. Now, this is one state, this is another state, maybe this is another state, this is another state. So similarly, we can think of 5 state, 8 state, 7 state, 10 state. But in reality, in computing or digital electronic or electronic, but when we say digital signal, right, all the time we refer to the binary digital signal. Unless it is an experimental thing where we just try to understand the theory, then only we use 4 state, 5 state signals. So therefore, our life is little bit easier because when we say electronic or digital electronic, we refer to binary digital electronic. The computer is binary digital electronic device. So therefore, in case we talk about digital signal, we always refer to a binary digital signal. Okay? Because computer can send binary digital signals, especially inside the computer between processor and RAM, your keyboard and RAM, and so on. Okay. The issue is sending this kind of signal long distance is the issue. But anyway, these we need to understand these digital signals, binary digital signals. Right. So then we discuss what is the difference between periodic signal and aperiodic signal. So periodic signal means the same pattern repeats, like our AC electricity. It's a sine wave. Because our electricity doesn't carry a data, it's just energy. So therefore, that is fine. So similarly, you have in your computer processor, you have something called computer processor clock. The clock generates this kind of a periodic binary digital signal, like your heartbeat. Okay. So those are called periodic signals. But in reality, mostly or more than 99.9999 in electronics, not in electricity, we are sending this kind of aperiodic signals. So this kind of aperiodic signals may be within the computer. Okay, it's a non-repetitive pattern. But when we learn about the basic concepts in signals or electronics, waves, usually we use periodic signals. That is to make our life easier. Okay. But in reality, what we work with is aperiodic signals. Okay. Right. So therefore, we start discussing some more concepts or features of a signal, but we refer to periodic signals to understand those. Right. So what are the concepts we discuss? So first we discuss what is amplitude. So amplitude is related to the strength of the wave at a particular time. Of course, in a periodic signal, that strength vary greatly, but in periodic signal also that strength vary. It goes positive, 0, negative, right? And again come back to positives after 0 and so on. So that strength can be measured using amplitude, the property called amplitude. And of course, it varies depending on the time. But usually when we say amplitude, we refer to this peak amplitude. Peak amplitude. Okay. So that is something you must understand. If someone says amplitude of the wave, so that refer to the strength or energy level, and usually the highest energy level. Okay, so this is low energy wave, high energy wave. So sometimes you say that, okay, signal is not there. I can't take a call. I can't connect to data. So that means, of course, when the signal transmitted from the tower, it was high energy, but it gradually has lost its strength. Its amplitude has diminished. So when it is below a particular level, your mobile phone or your router, wireless router can't pick it. It's too weak. So therefore, you must know that the property is called amplitude. So again, if you have any question, you need to ask. Okay. Because now we are into very serious topics. Network, programming, database, web. So the 4 serious guys. Right. So the next property we discussed last time, still we did all these things. That is frequency. So frequency is related of the definition of frequency is number of cycles per second. Again, we use periodic signal. So if you have 1 cycle per second, So then we say it's 1 hertz or 1 cycles per second. 1 hertz. If 1000 cycles per second, it is 1000 hertz. If half a cycle per second, it is half hertz. Okay. So usually this is high frequency, this is low frequency. If you refer to this as time, because you can see more number of cycles in a unit time. Okay. So if you take your FM radio, so maybe 89.5, 90.2, so that is different frequencies. Signal carries. But of course, those radio signals are not periodic, but in general, the frequency is that range for that particular radio station. So same for our mobile signals, Wi-Fi signals. So we use different frequencies. So maybe my Wi-Fi router use particular frequency, my next door, my neighbor's Wi-Fi use a different frequency. Otherwise, there will be conflict. So those who have configured a wireless router know that you can even manually specify what is the frequency range. But usually we use auto. So that means it detect any other radio waves and identify, okay, this frequency is not much used. So I will be using this one. This router will use this. So that is called what? Frequency. So then we look at what is period and wavelength. It is the same thing. We look at it in two different ways. So if you look at your wave, thinking that this is the time axis, time for one cycle is called period. Time for one cycle is called period. And therefore, remember frequency is number of cycles per second. So therefore, obvious frequency is 1 over period. F equal 1 over T. So T is measured in seconds. So usually it is in nanoseconds or milliseconds. But if you look at this as distance, because wave travels, right? So it started from that tower and the wave has reached your mobile phone, your mobile wireless tower, wireless router. So therefore, we can think of this line as length. So then this length of one cycle is called wavelength, lambda. It's the same thing if you look at it as time period. If you look at it as length, or you are looking at the visualizing the wave, then it is length, then we call it wavelength. So there are some waves which have higher wavelength and sometimes lower wavelength. So usually higher the wavelength, higher the period also. But again, it depends on the speed of the wave as well. So therefore, period and wavelength has a connection. And you can assume that all these signals travels in the same speed. Or at least a particular wave travels at a constant speed. But in general, all our radio waves and so blah, blah, blah travels at the same sort of a speed. That is pretty much same as speed of the light. Okay. So therefore, now we have a formula also. Remember, speed is for uniform speed, distance divided by time. If you take the speed of the wavelength wave as v, and if you take one cycle, the distance is wavelength, time is period. Period is time for one cycle. And we know that 1 over t is f. So therefore, we can say v equal f lambda because 1 over t is f. So we got another formula. Either you can say v equal lambda divided by 3 or v equal f lambda. So this is f equal 1 over. So those are the basic formulas in waves, wave transmission. And then we look at the last property that we are interested at A level, advanced level. when it comes to understanding waves and wave transmission, that is phase. Phase. So it is a little bit difficult or more challenging to understand than other concepts like period, wavelength, frequency, amplitude. So phase is relative time difference between two waves. Because it's not only one wave we are working with. Sometimes we work with multiple waves. For example, if you take radio, your radio is getting Sirius signal, Sun FM signal, right? City FM signal, right? So therefore, we can compare two signals as well. So phase is the relative time difference between two waves. Maybe this wave is going little bit earlier than this, or going little bit ahead of this wave. Okay. So it's a relative time difference between two waves. Of course, we can measure it using seconds, but more practical aspect is because this is related to the property of this wave, we can measure it in angle. So therefore, zero phase difference or phase shift means no phase shift. So that means those waves are sort of overlapping, one overlapping with the other. So then we say it's not out of shift, no shift between the two waves, no phase difference. But maybe one wave is going a little bit ahead of the other. Now we can say there's a phase difference. So the phase difference can be maximum 360. That is one period out of sync. So the 0 means no phase difference. 360 means one phase difference is the entire cycle. So that is entire cycle. So that is something like this. Say this is my first cycle wave and this is my second wave. So this is, maybe this is where my second wave start. So therefore this point, now this wave has already one period and then only the second wave start. So this point is correspond to this point of the other wave. So we say it is 25 or 360 out of phase. But if the second wave started somewhere here, so then it is 180 of 5 radians out of phase and maybe 90 degrees out of space if it start like this. Anyway, don't worry too much about that, the exact measurement, but you must have idea that there's something called phase, which is related to a signal or set of signals. Right, that's it. So that is the basics that you need to have. Okay. Amplitude, period, wavelength, frequency, and phase. And the two formulas, F is 1 over capital T and V equal F lambda. Okay. Right, so that is where we stopped last time. Okay, so any questions up to the last session? So because we have, this is our second session in networking. So if you don't have any questions and if you can do the exam questions, so you're okay. You're okay. But if you don't understand, you need to clarify before moving to the next session. Okay. Right. So as I told you, the computer is binary digital device. So computer represent everything in zeros and ones. That is why we did the topic called representing data in the computer, our second topic. And also it's processed by using Boolean logic gates, AND gate, OR gate, NOT gate, right? Say two signals like this goes through this and we get a different signal depending on AND logic. When both one are only one, Okay, when at least 1 is 0, it is 0 if it is AND gate. If it is OR gate, when at least 1 is 1, it is 1. So therefore, computer, inside the computer, especially when it's going through the processor, it is digital signals. It is digital signals. So therefore, we say that computer, we use digital signals. But I told you that sending digital signals from point X to Y is, you need a lot of energy, power. That is okay inside the computer, but not when I want to transmit my signal from my mobile phone to the nearby tower or my mobile phone to the satellite. That is impossible. Impossible. Because if you want to do that, you need huge amount of energy, which is waste of energy. So therefore, what we do is we transmit analog signals. But that analog signal represent that digital signal or that digital data. So that analog signals carry or represent your digital data. So that is something very interesting. That is something the computer engineers, electronic engineers have done. So they have built a theory. They have built some concepts to do that. So that is what electronic engineers are doing. Okay. And we understand, because this is ICT subject, this is not electronic subject, okay? So therefore, we need to convert digital signal to analog signal and analog signal to digital signal. Okay. Analog to digital, digital to analog. So that is called modulation and demodulation. So there you need to do digital to analog, but when you get the response, again, you need to convert analog to digital. So this is the internet side. Internet side, the telecom providers use analog signals, but your computer use digital signal. So here digital to analog, when you get the response, you get the analog signal which converted to digital signal and give it to the computer. So this is called modulation and this is called demodulation. So the device that is doing this conversion is called modulator, demodulator or modem. Okay, modem. But that is only special case of modulation. So in general, the word modulation has a slightly different meaning. But this is a special case of modulation, a big change. We are changing from digital to analog and analog to digital. So whether you are changing from analog to digital or digital to analog, we call it modulation, but pause. Clarity, one is called modulation, other one is called demodulation. And the device which is doing both is called a modem, because this guy need to do both, because sending and receiving. Right. Any question about what is modem? Okay, so this is a special kind of a modulator, demodulator. Okay, so there are some other modulator, demodulators, because we can even change this kind of a signal into this kind of a signal. So that is also called modulation or convert back. But that is analog to analog modulation, digital to digital. So that is why I told you that this modem is doing a special kind of a modulation that is converting even analog to digital and digital to analog signals. So these days you don't hear this word modem much. For example, when I get my internet connection in my latter part of 1990s, or maybe, yeah, early part of 2000. So I had to buy a modem to dial-up connection with the SLT, because SLT signal is analog, my computer is digital. So it go through the modem. But these days you don't hear this word much, because these days rather than a modem, what we buy is a router. So basically router has the built-in modem, and it does both the task of the modem and task of router. So therefore we just call it router. But anyway, the router has this feature. So basically inside the router you have modem. Right. So let's move on to our next subtopic. Remember, we are in the physical layer. Physical layer means how data signals are transmitted, signal level or electronic level. And remember, most of the time, we are interested in analog signal transmission because that is what happens your device to the towers, towers to towers, a device to satellite, and if it is wired communication like copper wire or something, again inside those wires, what we send is analog signals, not the digital signals. Obviously, when you say optical fiber, if you have fiber connection, so light is always analog, and you know that light is analog. So there we send light signals. So light signals are analog. So therefore, almost all the time, when we say long distance transmission, we refer to analog signals. So those analog signals also encounter problems. Of course, sending analog signals are a little bit easier, but it face issues. So those are called transmission impairments. Impairments. So some problems or distortions and so on that happens during the transmission. So these impairments can be due to two things. So one thing is always we need to transmit using a transmission media, maybe copper wire, fiber optics, or air. Air is also matter. So the inherent nature of these materials like copper wires, fiber optics may distort it. So that is internal sort of impairments. So the material, your media itself gives you some impairments, distortions. Because there's a resistance. You know that even for electricity, there's a resistance. You call it R. So that is why you got V equal IR. So that resistance prevent electrons moving from one place to the other. But that is electricity. So now we talk about electronic signals. So similarly, electronic signals also has sort of internal resistance. And then outside things. Outside agents can also create some impairments. So very good example is if you are watching television using the normal analog, right, outside antenna sort of a setup, or sometimes radio, you can see when there's a vehicle going by or helicopter pass by, all of a sudden you can see some blurs, some distortions, and so on. Okay, or thundering. So those are also impairments from outside sources. So we don't need to understand exact calculations, how much it is affected, but you must aware of what are those possible impairments. Okay. So imperfections in the media, okay. Some outside activities like man-made or natural activities. So man-made is something like you running your blender. Natural activity might be something like thundering. And sometimes these impairments happen due to crosstalk. That is two signals overlapping each other. Because maybe a particular wire is carrying hundreds of signals. So one signal can impair or distort the other signal. So likewise, there are impairments. There are different sources of impairments. So let's take one by one, but just you need to aware of these things. You don't need to understand exact science behind that and amount and blah, blah. That is for the electronic engineers. So they do those calculations and they come up with ways to reduce it or fix in some cases. So the first impairment is there is a natural situation because the natural resistance of matter or media to the propagation of waves, that is called attenuation. Attenuation. So you must understand this word, attenuation. So that is the natural reduction in signal strength or amplitude over the time. So you know that everything is impermanence in this world. Nothing is permanent. So is your waves. So when I talk, someone nearby can hear me. But someone far away, maybe 200 meters away, maybe he will say, I can hardly hear you because the signal strength diminish. So this diminish. That is natural thing, even in air, or even when we use copper wire or so on. So that is called attenuation. Attenuation. Okay. So energy tend to lost over the distance or over the time. So that is called attenuation. So there are some devices that we can fix this issue for some extent. Can anyone tell me a device that can fix this or at least try to improve this that you have heard? Anyone? In the transmission or electronics? Anyone with your O-level knowledge, or maybe you are doing some other technology subject? Maybe you are from tech stream. Anyone? No one. So I'm not expecting a correct answer, but at least some sort of answer. For example, about 10, 20 years ago, when we were using the normal television signals, of course, these days we have the satellite TV. So almost every house had a device doing this, boosting this attenuated signal back to high strength signal. So we call it booster. So booster try to say this is my original signal. This is my new signal. Now strength has decreased everywhere. So it will again boost it to this kind of a level. So boosters, repeaters. So we need those devices because of this attenuation and other phenomena, but mainly due to attenuation. Okay. Natural strength reduction in strength of our waves. Right. So the second one is called white noise or thermal noise. So this is more a concept, but this is more a reality or the reason for attenuation and other issues. So the reason for attenuation is, especially when it goes through something like copper wire, we call it white noise or thermal noise. So thermal noise is the resistance from the matter or the electrons for the transmission of the wave. So it's something like similar to the normal resistance in electricity. So that resists the flow of electrons, but then you call it normal resistance. But if it is the resistance to the propagation of wave, we call it thermal noise or white noise. And some materials have more white noise than other materials. Just like some materials have high resistance than other materials. For example, copper has a relatively low resistance. Gold has even low resistance, but very expensive. Iron, cheaper, but high resistance. So therefore, we settle for copper for electrical things. And for electronics also, good news is copper has a relatively less white noise. So that is why for both electrical and electronic things, we use copper. So copper is having low electrical resistance as well as relatively low thermal or white noise, the resistance to propagation of wave source. Okay, so that is called what? White noise. So white noise is the main reason for attenuation. Okay, main reason for attenuation. Right. So next impairment is called delay distortion. Delay distortion. So just be aware of this word, okay? You don't need to go into details. So delay distortion means when we take one wave, remember it can also have different frequencies. Same wave can have different parts having different frequencies. Okay, maybe this one has high frequency, this part of the wave has low frequency. So there's a tendency that high frequency waves move faster and low frequency parts move slowly. So it's like your left leg is moving fast, right leg is moving slow. So then you are out of sync, right? ඔයාගේ වම් කකුල හයියෙන් යන්න හදනවා දකුණු කකුල හිමින් යන්න හදනවා. එහෙම නැත්නම් බල්ලෙක් වගේ නම් ඉස්සරහා කකුල් දෙක හයියෙන් යන්න හදනවා පස්සේ කකුල් දෙක හිමින් එන්න හදනවා. එතකොට බල්ලට ඇවිදින්න බෑ දැන්. කන්ෆ්ලික්ට් එකක්. So the reason also, if you want, you can deduce by this formula, F equal V lambda or V equal F divided by lambda. So this part has high frequency. High frequency means high velocity. Say this part has low frequency or relatively low frequency. So that means low velocity. So this part try to move fast. This part try to move slowly. It's like a dog having the two front legs try to move fast, but the back legs doesn't support that. So it stretches the dog. So similarly, it distorts the wave in different areas. But that is very small, but still that distortion can happen, especially when you are sending long distance like satellite. And these days we talk about getting waves from Mars and far away from the universe. So that distortion can be significant. So that is called what? Delay distortion. So the reason is high frequency part tend to move faster than low frequency part, that you can understand using this formula. So that can create sort of a shrinking and stretching of your wave. So that is called delay distortion. So that is another possible distortion or impairments. Impairments means distortions, imperfections to the wave. So what we receive is not the original wave because of these things: thermal noise, delay distortion. So the next one is crosstalk. So as I told you, if you take a channel, it is usually not just one signal we send in a channel. Right. For example, if you take, say, your telecom cables, maybe you are living in a particular street or road, maybe thousands of people using that that line. Maybe just 2 or 3 telephone lines, but hundreds of people can use it at the same time. So that means that one line is carrying, say everyone is talking at the same time. So everyone is using internet or everyone is using cable TV. So hundreds of signals travels in a particular channel. So that means multiple signals are sent using the same channel at the same time. And one signal can distort the other signal if you don't take precautionary steps. Of course, we take precautionary steps to minimize this. Still, if that's can happen. If it happens, we say there's a crosstalk. Crosstalk. So why do we call it crosstalk? Because I don't think that you have experienced this much, but about 20 years ago, when we used our telephone lines, especially wired telephone lines. So when I take, say, when I take call to Y all of a sudden in the middle, sometimes I can hear another conversation. So that is crosstalk. Some other signal has overlap with my signal. So that was a sort of a frequent thing at that time. Frequent thing, it doesn't happen all the time, but maybe when you take 1,000 calls, maybe one time you have experienced crosstalk. So the same word we use, of course, these days we are sending data signals. Still, we use the word crosstalk because that was something we experienced. So therefore, still we use the word crosstalk when one signal can overlap the other signal and distort it. Right. So that is one of the reason when we take copper wires for data transmission, we twist it. So one of the reason we want to twist is to reduce the crosstalk. Reduce the crosstalk. So that is why you need to understand these things, because otherwise you don't know why these wires are twisted rather than you keep it like this. That is one of the reason to reduce the crosstalk. Okay, but that is just one of the reason. Right. So crosstalk is another impairment. Another impairment. Then of course there can be external interferences like thundering, mechanical devices like your vehicle, blender or something. So that can distort a signal. Okay. So that is why especially those distortions are affected to wireless signals or signals carried through copper wire. But this external interference is less for fiber optics or fiber signals. Light signals travels through fiber. Okay. But anyway, it is not zero. So that is called external interferences. Okay. Right. So that's it. So what are those? Thermal or white noise, delay distortion, crosstalk, and external interferences. And of course, the natural phenomena related to white or the thermal noise, we call it attenuation. Okay. So we are now doing one subtopic by one subtopic, right? Going forward. And we try to understand how the waves or your data is transmitted at physical level, wave level. Right. So now we look at what is meant by channel capacity. Because you may have heard something like my internet speed is this bit per second, or some people say this megabyte per second, this megabit per second. And you can even check what is your internet connectivity speed and so on, right? For example, say check internet speed. So there are online tools also. So you may be using these things, okay? And it gives you your speed, download speed, upload speed, after sending some test data signals here and there. So of course I have reasonably high speed internet because I am using fiber optics. So you can see it's about let's see. So my download speed is 72.51 megabit per second. And download speed looks pretty much 100. Sorry, upload speed is pretty much 100. So that is sort of a very good one. But if I connect using my Mobitel connection, wireless connection, so this is not 72, maybe this is about 10 to 20. And maybe this is again around 10 to 20, 30. So that is measure of my channel capacity, megabit per second. Okay. Right. So let's look at little bit of theory behind that. Channel capacity. So they will say, okay, this is the capacity of our internet connectivity. Say ADSL, this is the capacity you get. Wireless, this is the capacity. So now people are talking about Starlink also, direct satellite internet. So they have very high capacity. And when we move from 3G to 4G, one of the improvement is increasing the capacity. 4G connection. Right. So first of all, you must know what is meant by channel. So this word is heavily overloaded. Different people use in different contexts, but mostly they are related. So the most popular usage is TV channel, right? TV channel, radio channel. But that is one particular frequency range or frequency is called a channel. But in general, when we say channel, it's a communication link between two points. Right? Say maybe you have one tower and another tower. So we say that there's a channel, communication channel, or maybe this tower and your smartphone. Or maybe you are not only you, maybe some others are also using. So maybe you are sharing that channel. So it's either physical transmission media, if it is wire, because we can see it, or logical connection over a multiplex media. We will discuss what is mean multiplexing. Multiplexing means multiple signals travels through one channel, and then it is demultiplex. Okay, so channel. So channel means basically either physical media or basically yes, it's physical media. Okay. Maybe it's shared by multiple parties for multiple communications. Okay. So then the bandwidth. Bandwidth. So bandwidth, the word bandwidth has two meanings. Actually, the same thing. Electronic engineers look at it in one way, computer engineers look at it in another way. But basically, we look at the same thing. So therefore, sometimes you get confused because maybe one book refers to one way of looking. It's the same thing. You look at it in different way. Okay, so the concept is there, but maybe electronic engineers look at it in one way, computer engineers or digital electronic engineers look at it in a different way, but you look at the same thing. Right. So what is the view of electronic engineers in general? So they will say bandwidth is frequency range of that channel. Range of frequencies that can pass through that channel. Okay. For example, if you take FM radio, so there's a bandwidth. So maybe highest is maybe 99 point something or closer to 100. I can't remember. And there's a lower limit. That range is used for FM transmission. If you take your fiber optics, so if they have a frequency range, only within that frequency range, signals are sent. Or even copper wire, satellite communication, or maybe a tower to tower. So when this tower communicates with this tower, it sends only signals with say this particular frequency to this particular frequency only, not less than that frequency or more than that frequency. That is called the bandwidth. That is called the bandwidth. So usually higher the bandwidth, better. So that means you have more opportunities to send multiple signals. But these bandwidths are limited. So that is why we have the telecommunication regulations and so on, right? So the bandwidths, you need to get the license to use some bandwidth. Some bandwidth. Because bandwidths are limited. So therefore, we try to get the maximum out of the bandwidth. So that is frequency range. the electronic engineer's view of bandwidth. So in general, higher the bandwidth, better. That means you have more opportunities, more possibilities to send multiple signals. But computer scientists or computer engineers' view is that is what is your data rate? Maximum data rate or maybe average data rate or minimum and maximum? So that is called bandwidth, because usually higher the frequency range, higher the data rate also, because you have more ways to send data or more people can share it. So therefore, some people will say bandwidth, they will say, okay, bandwidth is 100 megabyte to 200 megabyte. So that is electronic engineers' view of bandwidth. But maybe someone will say my internet connection bandwidth is 100 megabit per second. That is 0 to 100. Maximum I can go for 100 megabit per second. So that is also bandwidth. Right? So it denotes one way speed, other way how many people can share it. Maybe if I use it alone, maybe 100 megabit. If two computers are connected, maybe then each computer might feel it like each computer get 50 megabit, because this is shared now. So that is called what? Bandwidth. So bandwidth can be frequency range like hertz or bit per second. Bit per second. Right. So now we look at another concept. So we are just building the terminology, the basic concept, so that we can understand the more complex, sophisticated concepts later on related to computer networking. Of course, computer networking is a technical subject, right? Now we are into the technical subjects. Programming, computer networks. Right. So when it comes to communication between two ends, so when I say communication, it can be any type of communication, maybe voice communication. That is what we do in your telephone calls, so mobile calls. Or it can be data communication, sending data from one point to the other point. So whatever the communication, whether it's data or voice, we can identify three type of communication. What are those? Simplex, half duplex, full duplex. Okay. So this is a very simple concept. So simplex means one-way communication. One-way communication. Maybe A can send signals to B, but B can't send signal to A. That is not that facility is not there. So then we say it's simplex communication. So very good example is when you listen to radio, TV, it's one way. Your radio can receive signals and now you can hear the radio, but you can't send signal to the radio station. There's no such facility in the radio for you guys to send signals or send some feedback to the radio channel. So that is why if you want to talk to the radio channel, you need to take a telephone call at least. So that is called simplex communication, which is very restrictive. And that is why radio, TV, these technologies are now getting obsolete. People hate this. Of course, they loved it about 20, 30 years ago because we had no option. But now we hate it because this is not democratic. These guys talk, we just hear. So we are like slaves. We are like slaves. We have no voice. So only stupid people use radio and television anymore. Stupid people or lazy people. So that is why people are moving away from television and radio to the internet, social media. So that is where we have our voice power. We not only hear, we communicate back different ways, like it, share it, comment it. Or we transmit things so that others. So remember in television, radio, they transmit we listen. But if you go to social media, we can also transmit. So you can go live in Facebook, YouTube, so that others, so you are something like radio station now. Of course, if others are willing to listen to you or watch you. So therefore, simplex is getting less and less used these days. But anyway, that is called what? Simplex communication, one-way communication. The second approach is called half duplex. So that is improvement. It's a two-way communication, but one way at a time. One way at a time. So when the communication is this way, you need to wait until this communication stop, and then you can initiate this way. And during this way communication, now X can't send Y signals to Y. So very good example is all walkie-talkies. Now even the walkie-talkies are also now pretty much getting into full duplex. All walkie-talkies that especially the police and they use, so they just take the control and then they talk, right? Because it's not two-way. At a time, only one way. Then you take the control and say, okay, now I want to send something. So then you send it. But during that time, the other guy can't send. So that is called half duplex. So half duplex is better than simplex, but it is restricted. So therefore we had some usages and still we have some usages, but it's not the best solution. Because though two ways, they are only one way at a time. So the third approach is the more sophisticated approach where full duplex. Both ways simultaneous. At the same time, transmission can happen in both ways. So that is why when you take a telephone call, while you talk, the other guy also can talk. So you can hear what this guy, why is saying. While you listening to why, you also talk. It's full duplex now. And your data communication is full duplex, internet connectivity. So therefore now almost everything is full duplex. Okay. But there are some technologies which are still half duplex, but because it can change this very quickly, we feel it like full duplex. Okay. For example, if you take something like Wi-Fi, so though we say Wi-Fi is full duplex, in reality it is half duplex. But the way it is done in a very efficient manner, we don't feel it like half duplex. Right? Anyway, that is an additional thing. Just remember, full duplex is two-way simultaneous. Half duplex means two-way, but only one way at a time. Simplex means one way. Right. So that is another subtopic. You can see we are doing a lot of small subtopics. Small subtopics. Actually, now we are moving to our most important subtopic under physical layer. That is physical media. Remember, physical layer, we are interested in how the physical media transmit data, then how we can physically connect things like topologies. So those are our main concerns. And this is one of our main concerns. The classification of physical media. So let's first classify physical media that we used in computer networking and in general telecommunication. Okay. So we can broadly categorize as wired or guided media. That includes copper and fiber optics, copper wires and fiber optics. Copper wire we can subdivide into twisted pair and coaxial cables. So those are the wired or guided media. Guided means physically you can see it is the way signal is guided. Of course, you can't see the signal, but at least you can see the media. So second category is wireless or unguided. In wireless, of course, the signal transmit, the wave transmit, but you can't see the physical media because it's air. So therefore, we call it unguided. But it doesn't mean that for example, when you have two towers, it doesn't mean that your wave goes here and there and go, right? It goes like this, but no physical thing, that physical visible thing to guide it. The wave just go in the natural way. And sometimes these waves can even bend and go also when there's obstacle. So therefore we call it unguided media or wireless. So they are the only difference is depending on the frequency. Now that is why we discuss about frequencies, wavelength, and so on, right? So depending on the frequency, which frequencies we use, we call it infrared, radio waves, microwaves. Of course, there are some other type of waves, but for the telecommunication, we use only infrared, radio, and microwaves. Okay. Right. So let's take one by one with copper wire. So as I told you, copper wire is heavily used in electrical engineering because it has very low resistance and reasonably cost. Of course, there are even low resistance, but those are very expensive. And luckily, the same material is good at transmitting signals with low thermal noise, so the white noise. You can see now I'm using those words. Okay, I'm using those words. So therefore, we heavily use copper wire as guided media. So there are two types of copper wires we use, twisted pair and coaxial cables. It's reasonably cheap and already used in electrical field. So therefore, these wires are readily manufactured. Disadvantage is compared to other alternatives right now we are having like fiber optics, it is relatively high noise and low bandwidth. So that is why low bandwidth means now you know what is bandwidth also, right? So bandwidth means either frequency range or data speed, bits per second. So if you have ADSL connection, you have low bandwidth. But if you have a fiber connection, you have high bandwidth because copper wire has low bandwidth because of this noise and other things, whereas fiber optics has relatively high bandwidth. So we build knowledge, right? Bit and bit, right? So we use these concepts to build the next level of things. So therefore, remember this is computer information technology is part of the formal science. So you should be able to understand 100% of your syllabus. This is not like you try to understand physics, chemistry, biology, right? No. Those subjects you can't understand 100%. Don't try to understand 100% because you will end up as a crazy person, right? In mental hospital. If you try to understand 100%, even Einstein has not understood it 100%. No one. And no one will understand it ever in the future also. But these concepts we can understand 100%, not electronic things, computer engineering things, software development things, information technology things. Okay. So don't settle for 90%. Right. So now you must have some idea about copper wire. Right. Relatively cheap, convenient, but it's not the best when it comes to bandwidth and impairments. So let's first take the twisted pair. Remember twisted pair coaxial cables. So twisted pair means twist means umbrella twist. So that is a twist basically. Okay. So twisted pair means that is the most widely used in our normal wired local area networks. Right? Wired local area networks. This is frequently used, and this is the most widely used, and it is the cheapest and easiest to handle. But this is not the best when it comes to bandwidth. Right? Bandwidth is relatively low and a lot of impairments like noise and so on. So as I told you, why do we twist it? To reduce the crosstalk. Reduce the crosstalk. So we use twisted pair in local area networks and mid-range, not very long distance, maybe from your home to the nearest distribution center, maybe few meters or less, maybe 200, 300 meters these days. About 10, 20 years ago, even for kilometers, we used twisted pair, but these days we don't use twisted pair much. But especially within local area networks, wired local area networks, we use twisted pair heavily. Okay, right, that's it. We don't go into detail because this is not electronic engineering. This is ICT. So the second one is for copper wires. Sorry, when it comes to twisted pair, just you need to understand two more things. There are two variations of twisted pair. So what is known as UTP or the unshielded twisted pair and shielded twisted pair, STP. Okay, STP. Right. Unshielded twisted pair and shielded twisted pair. So the word itself says the shielded twisted pair, each twisted pair is shielded with an aluminium foil. Right, aluminium foil. So therefore, it further reduces crosstalk and interferences. So therefore, STP is better when it comes to bandwidth than UTP. But of course, STP is slightly expensive, not very expensive, relatively expensive than UTP. So therefore, if you are interested in relatively high speed and maybe relatively longer distance, we go for STP. But for very simple applications, UTP is also good enough. Okay, but both are twisted pair. Both are twisted pair. Okay, UTP, STP. Now, if you go to an electronic shop, even hardware shop, you can go and buy UTP cables, STP cables. They have. So when you say twisted pair, they will ask, do you need UTP or STP? Or they very specifically they will ask, what is which standard UTP you need? Because those in the electronic area and computer networking area, they know exactly what type of STP wire they need, what kind of a UTP wire they need. Okay, but you just need to aware that there are two type of twisted pair called UTP and STP. And UTP is better than STP, though it is slightly expensive. Right. So the next type of copper wire usage is coaxial cables. So this is not new thing to you guys. If you have ever worked with a physical antenna, that is normal antenna, not the satellite television. So you know the real headache connecting these devices. Okay. So coaxial cable. Why do we call it coaxial? Coaxial, same axis. So this is the axis. This is one conductor. This is the other conductor. So this is one conductor. The other conductor is in the same axis. Another set of mesh of wires. Mesh of wires. Again, copper wires in an aluminium foil. And this is the insulator, parivarakya. So prevent interferences. Right. So you have the central conductor, then the outer conductor. It's sort of a mesh and insulator isolating the inner conductor and the outer conductor. And then the jacket, which is another insulator. Insulator can parivarakya. Right. And in general, these coaxial cables have better bandwidth. මම දැන් ඔන්න වචනේ පාවිච්චි කරන bandwidth. ඒ කියන්නේ මොනවද? Data capacity එක වැඩි, speed එක වැඩි. Okay. So therefore, this is better, but only thing is this is bulky. This is bulky cable compared to twisted pair. So therefore, not very convenient for use in our home environment or even office environments. So that is why we go for twisted pair, though this has better bandwidth. But we heavily use coaxial cables, especially before fiber optics came, for long distance wired communication. Even we use coaxial cables in the sea lines, internet backbone. And still we use coaxial cables by telecom providers when they are using long distance transmission. But these cables are now gradually replaced by fiber optics. Because this is a very bulky thing, no one like to work with this. So better alternative is fiber optics. So therefore, coaxial cables are getting less and less popular. Of course, not only coaxial cables, even the twisted pair is getting less and less popular. One reason we go more and more wireless. Second reason, we use more and more fiber optics. Maybe after sometimes, maybe all telecommunication will be fiber optics. No copper wires. No copper wires. Still, that is not the case. But the fiber optics is getting more and more popular than copper wires because fiber optics has less interferences and very high bandwidth compared to copper wires. Okay. So coaxial cables relatively high bandwidth compared to twisted pair, but it's bulky and more costly. Okay. Right. So that's it about copper wire. Our next guided media is fiber optics. So fiber optics is relatively new and it has become sort of very dominant these days. So the major internet communication is happening. If it is physical media, almost all the time fiber optics. And now we can get even our internet connection to home using fiber optics as well in Sri Lanka in most of the areas. So there we use light signal. It's a fiber optics like a very special type of plastic or sort of a mixture of plastic and glass which carry light signals, not the normal electromagnetic signal. So these light signals move super fast and very little distortions, right? And very little natural interferences and also internal interferences. So therefore very high bandwidth and speed. Very high bandwidth and speed compared to other technologies. Okay, fiber optics. So very low noise, very high bandwidth, and also better security also. Difficult to interpret this. Electromagnetic wave, sometimes outside person might interfere it, sense it by sensing the wire, but it is near impossible when it comes to fiber optics. It's very difficult to sense it and identify what are the waves going on. Okay, fiber optics. So the disadvantages, of course, it's a relative thing. Still, fiber optics technology is relatively new. So therefore, still it is relatively expensive, but it's not, it's getting less and less expensive. And after sometimes it will be even cheaper than copper, right? Copper wires. So fiber optics are still used in mid to long range transmission, but even for short transmission like fiber to home, and even with our local area networks also we can use now fiber optics. Of course, people use fiber optics, replacing even twisted pair copper wires because it's so fast and less interferences. It's more reliable. Okay. So it's getting the most or the physical media and getting more and more popular. Okay. That is called fiber optics. So how does fiber optics transmit your waves? It uses something called internal reflection. पूर्ण अभ्यंतर परावर्तन. So when a light signal sends, it keep reflecting inside the material and move forward. It is not reflection. පරාවර්තනය නෙමෙයි. මේක reflection නැත්නම් කියන්නේ මොකද්ද අපි සිංහලෙන්? පරාවර්තනය refraction කියන්නේ මොකද්ද? මට හරියට මතක නැහැ. කියන්නේ මෙහෙම ගියාම මීඩියා එකට පොඩ්ඩ ඇලවෙනවා. ඔන්න ඇලවෙන එක මේ ඇන්ගල් එක වැඩි කරාම මේක රිෆ්ලෙක්ෂන් වෙන්න පටන් ගන්නවා. ඔන්න ඕක තමයි යූස් කරලා යවන්නේ fiber optics එක. Right? Total internal reflection. Okay, total internal reflection. So we use that property to send light signals. Light signals. ඇහැට පේන light signal එකක් කියන්නේ යා. Right. So therefore when we use fiber optics, so you need three things actually. Of course, we need a media, which is usually plastic, very high quality plastic, or mixture of plastic and glass and fiber. Okay. And then you need light source, which can generate the light signal, and another device which can detect the light signal. Other. So this generate the light signal, and this transmit the light signal, and this can detect the light signal. Of course, not just one signal. Thousands of light signals can be sent in the same bandwidth, same wire, parallelly. There are ways to do that, multiplexing, demultiplexing techniques. Right. So when it comes to light source, that is this. So we use two major light sources, either LED or semiconductor laser. Just be aware that those are two light sources. That is enough for A level. But just remember, LED is little bit all the way. Semiconductor laser is more sophisticated, high-speed approach. Right, high-speed approach. For long distance, we use semiconductor laser like the C lines. But for short distance, we can use the LED light signals, light source. Okay, cost is also less for LED, but semiconductor laser is for long distance, high speed fiber connections. That is the source. Then you need a detector, the receiver. Of course, both sides must have detectors because it's two-way communication, right? So don't think that only one side has the source, other side that no. Both sides has both detector and source. So detector can detect the light signal and interpret it. And maybe it can generate an electrical signal because now we are sending it to the computer. Computer is inside the computer. We don't use light signals. What we use is electromagnetic waves. So it interpret the light signal, incoming light signal, and generate your electromagnetic signal. Okay. And then of course the media itself. Okay, media itself. So there are different grade of fiber optics cables. Okay, you don't need to worry about those things, right? Right. So now we discuss two wired communication technologies, copper wire, twisted pair and coaxial, then fiber optics. So next one is power line communication. This is not a major approach, so that is why we just take it third. But actually, this is theoretically, this must also come into the copper wire, right? Copper wire. But because this is rarely used or less used, and in Sri Lanka, I think not at all use. I think the CEB is trying to use this technology for the remote metering technology, but I don't know whether they are using it or not yet. So power line communication means, remember, we almost every home, every house, or every place, every factory, we get electricity. So electricity is not something so far possible to transmit wireless. So there's an electric cable coming to every house, every factory, every business organization. So the idea is power line communication is use that line, use that cable, that electric cable or electric wire to send data signal, communication signals. Okay. So then we call it power line communication. But this is not frequently used. This is sort of a research area, and there are some limited usages on it. But anyway, you must aware of this word, power line communication, because these power lines are everywhere, right? So if we can use it, that is good. And it's going to be very cheap also, because the infrastructure is already, the only thing is we need to separate the electrical signal and extract that, the communication signal, right? Other thing is the security, right? We must make sure that the electrical shocks are not transferred to the communication devices. Okay, but There are ways to isolate that. So that is called what? Power line communication. That is just for your information. Maybe in the MCQ question, examiner can ask. Right. So now we move on to unguided or wireless transmission. Right. Unguided or wireless transmission. So unguided means there's no physical wire or physical tangible media. අතට අහුවෙන ඇහැට පේන දෙයක් නැහැ. Still we can transmit signals. So that is called wireless transmission. So obviously the biggest advantage is it's more convenient because there are no physical things. Installation must be easier because there are no wires. It must be good for the people and also mobility. If we can send very long distance, that can, of course, that is the nature. We can use it for very long distance because, say, from Earth to Mars, it's not practical to have a copper wire or fiber optics. But still, we can communicate between Mars and Earth using wireless communication, satellite communication, right? Unguided transmission. And again, we can identify 3 frequency ranges which are heavily used as 3 technologies, but it's more the technology depends on what frequency we use. Okay, infrared, radio waves, and microwaves. So this is not something you need to memorize. So this is to give you that confidence. So we have something called electromagnetic spectrum, Vidyut Chumbaka Varnavali. So visible light is also there. Visible light. So remember, we can use visible light also for data transmission, fiber optics. But that is a guided medium. So therefore, visible light, still we use only in guided media. Of course, we can use visible light for unguided media also. There's another one called Li-Fi, just like Wi-Fi. We send light signal as a wireless media. Anyway, that is not something we are going to look at right now. But other than that, we have radio signals, infrared, and ultraviolet. Sorry, not ultraviolet, microwave. So ultraviolet is not used because it is harmful. Sorry for that. Microwaves. Okay. So what are the 3 bandwidths we use? So in this electromagnetic spectrum, when we go right side, it is more higher and higher frequency. High frequency means high energy. So that is why ultraviolet is harmful. X-ray is, if you expose too much, it is harmful. That is why when someone take an X-ray, they take all the precautions, and if it is absolutely necessary, only they take X-ray. And gamma rays are super harmful. That is generated in nuclear bomb blasting and so on. But left-hand side of visible light, they are not that bad. Of course, we can expose to light also, right, without much issue. So what are those? Now, this is high strength or high frequency, high strength. This is less frequency and less strength. Okay. And again, radio waves also we can subdivide FM, AM, part is for TV and so on. Don't worry about those things. Just remember something like this. You have the visible light, then you have the infrared, radio waves, sorry, microwaves and radio waves. And here you have the X-rays, gamma rays, which we don't use. And this is your visible light. That's it. You don't need to remember anything else like frequency ranges and so on. No, nothing. Okay. Right. So some of the frequency ranges anyone can use. But some other frequency ranges, it's under the control of the country. For example, microwaves and radio waves, you can't just use it without the getting the license from the government. But there's a part of the radio waves you can use it as well. That is what we use in Wi-Fi. And infrared, of course, there's no need for get any license from the government. So that is why, for example, you can't run a radio channel. Right? Government is going to take you to the custody because radio frequency range is something you must get the permission, pay license fees. But you don't need to take permission or pay license fees to set up a Bluetooth network, Bluetooth wireless, or Wi-Fi network. Because those limited frequencies are anyone can use. And of course, the infrared. Okay. So some frequency ranges are prohibited for general public to use. Some frequency ranges are allowed. And we can set up our networks using those frequency ranges. Other ranges, only telecom providers use, like in Sri Lanka, Dialog, Mobitel, SLT, and so on. Right, so let's take one by one. Starting with IR, infrared. Infrared means, remember in electromagnetic spectrum, this is visible light, this is red, this is violet. So infrared means less than red, infra. This high, this way high frequency, this way low frequency. So this is infrared, frequency is less than red. Similarly, this here you have the ultraviolet, more than violet. Right? Ultraviolet, more than violet. It's high energy than violet. But this is less energy than red. Okay, and red is visible to our eyes, but infrared is not visible to our eyes. It's very close to light, but it is not visible to our eyes. Maybe some animals, I think, can see infrared signals or infrared as a color. Right. So it's a short distance. Infrared is short distance. So usually we use it in our, mostly we use it in our remote controls. And also sometimes as an alternative for something like Bluetooth. But this is the main issue is line of sight. So this is a word you must know. Line of sight means if X point wants to communicate with Y points, you must be able to draw a straight line and without obstacles. So that is why when your TV is here and you are here, when there's someone in front sitting in front of you, you can't use it. You need to take your remote here because line of sight is not there. So these signals are so weak, they can't go through the obstacles or go around the obstacles. Go around the obstacles. But this is good enough to transmit very short distance, like maybe your computer to the printer or create a personal area network, or obviously usages like using remote control. So of course, remote control is usually nearby you, like controlling your television or some like controlling your AC. So that is where we use infrared. So infrared, you don't need to take licenses from the government. You need the line of sight, and it's a very weak, so therefore only few meters maximum without obstacles. And there are some usages, very simple usages. Okay, like personal area networks as a remote control and so on. Or peripherals, like maybe infrared mouse. That is basically communication is also infrared. Okay, usually wireless mouse use Bluetooth. Right? That is infrared, very weak, very short distance communication with very specific usages only. So as I told you, so this is a relatively new concept. If we can use infrared, why can't we use light? The only thing is light is visible, so therefore we need to use a very weak light signal which does not interfere humans. Otherwise, humans can see the light, which is not convenient. Okay, so then you call it Li-Fi. So you better you remember this word, Li-Fi is similar to Wi-Fi, but we use light. Okay, but in fiber optics, we need a guided media, fiber cable, optic cable. But here you don't need cable. It's basically we just use light as a signal. Okay. So there are some special situations where radio signals are dangerous. Maybe some medical equipments or maybe something like travel space communication or inside a plane or something where things can interfere with other devices like aircrafts. So if you feel like your radio other signal like radio wave can interfere with other devices, a possible solution is use Li-Fi because Li-Fi frequency range is different from your radio wave frequency ranges. So likewise, there are very specific usages and still this is emerging technology, right? So in the future, maybe this will become one of the major technology or we never know. But still it is not a very popular technology. Okay, Li-Fi. Use of light signal as a wireless communication. So then we have the radio waves. For example, when do you use radio waves? Obviously in radio, right? And also when you take television also, though we say radio waves, pretty much we are using pretty much, so though we don't call it radio waves, it is still sort of the same sort of the frequency range. And of course, when you connect to your nearest tower, your smartphone or your wireless router, so we use radio waves. Okay. So radio waves, of course, you need the license from the government to use those frequency ranges. And we use omnidirectional antenna. Omnidirectional means a normal antenna where it can generate signals everywhere, every side, all directions, and also receive signal from any direction. That is called omni. Omni means all direction. So omnidirection means normal antenna. But these days you don't see the antenna because they can make this antenna very tiny. For example, about 20 years ago, our mobile phones had antenna like this. But these days, your mobile phone, you don't see antenna because antenna is so tiny. Because the things are very powerful now. But anyway, that antenna is still there. And it is a omnidirectional antenna. And those towers also have omnidirectional antennas if they use radio waves. So that is why whether you are left of the tower or right of the tower or whatever, you can get the signal. Because radio waves use omnidirectional antennas. Okay. And it's fairly high bandwidth, but not the best bandwidth. It has limitations. It has some limitations. Okay, radio waves. So we use radio waves for telecommunication, like of course we use for radio and TV broadcasting, and also tower to our mobile phones, or maybe we can use it for Wi-Fi network. Wi-Fi network also use radio waves, a specific small frequency range of the radio waves. Okay. So the next one is microwave, the last one. So microwave is higher strength than radio waves. So we use microwaves frequency range for two reasons. Two usages are there. That is tower to tower, which is far away, right? Say tower to your mobile phone is maybe maximum 2-3 kilometers. Maybe you are very close to the tower, or maybe 2-3. That is why you have towers everywhere. So when you are going far away, you are connected to the other tower. That is why we call it cellular technology. It's like a cells. You are connected to this tower. When you move away, you are connected to this tower because radio transmission is only few kilometers. Only few kilometers. So that is why we need towers maybe every 4-5 kilometers. The Mobitel has towers. Dialog having their own towers. So they have thousands of towers all over the country. Because radio waves, that is how it works. And of course, when it comes to radio and TV, you know that it can send signals far away, but that is not very quality signal. But when it comes to long distance transmission, we have a better high strength signal called microwave. Microwave. So microwave signals can be sent far away, maybe 30, 40 kilometers. Mostly tower to tower is this. And you can see parabolic antennas. So those are unidirectional. So this tower is sending signals to this tower, not broadcasting everywhere. Because microwaves, we use unidirectional parabolic antenna. It's high strength than radio waves. That is one usage. Second usage is your dish antenna to the satellite and satellite to the antenna. Of course, you can use small antenna if you are receiving, but if you are a transmitter, you use very big parabolic antennas. So that is, your satellites are far away, right? Hundreds and thousands of kilometers away. And it can send to the other part of the Earth. So there also we use microwaves. So those are the two usages of using microwaves. Our parabolic antenna to satellite and vice versa, tower to tower. And those are always unidirectional. And there's a higher strength and higher bandwidth in microwave transmission. So longer distance and higher bandwidth. Okay. Right. Any questions? So we covered a lot. I think we covered too much. Right. Still we are halfway. Because remember I told you we have more content for physical layer and logical link layer. Logical link layer we have lesser content than. Logical link layer we can do it in 1 day. But physical layer we need 2 days. Then the network layer we need at least 3 or 4 days. That is where all your subnetting, IP addresses, routing, the big topic is there, network layer. So then other layers, those are very small topics. Transport layer maybe just half a session. Application layer maybe another 1 or 2 sessions. So then networks. Remember, network topic is one of the biggest topic, and usually students consider network topic as, if not the hardest, the one of the hardest topic. In general, students consider network as a harder topic because other topic like programming, some students find it easy because they have that programmer mindset. Some students find it programming topic difficult because they don't have that mindset. ඒගොල්ලන්ට programming mindset එක නෑ. ඒගොල්ලෝ program කරන්න ආස නැති අය තමයි ඒකට ආස දුර්වල වෙන්නේ. හැබැයි network topic එක හැමෝමටම challenging. හැමෝටම challenging network topic එක. Because so much of things for you to understand, and you need to put everything into the same one context and understand also. First, you need to understand isolated things. So then on top of that, you need to understand the next level of things. So that is why it's very important that you understand these things. So unless you understand the physical layer concept properly, so then when we go to the logical link layer, then all of a sudden you will find that, okay, I don't understand. What is this? It's Greek. No, it is not Greek, that you haven't spent enough time with the physical layer, the basic concepts. Remember the concept like what is frequency, what is amplitude, what is phase. So those are super important. What is analog signal? What is a digital signal? Right? So what are the drawbacks? So what are the features of analog signal, digital signal? What is binary digital signal? So that is the most important things. Based on that confidence, you can understand different physical media, and then later on what is encoding, decoding, multiplexing. So now we are into the serious stuff, data encoding, decoding. Okay, all these things are in your syllabus. Okay, Manchester encoding, then modulation, demodulation. I told you that modem is doing a very special type of modulation, demodulation, but modulation and demodulation is more general concept, because you can have the analog to analog modulation as well. Okay, so we will look at what is AM, FM, PM. Right. So those are very interesting. So then multiplexing and demultiplexing. Then what is packet switching? What is circuit switching? So packet switching is used in computer networking. Circuit switching is used in telecom. Then of course the network topologies, that is the easier thing. Star, bus, ring, tree, and so on. And how the hub work. Hub is a device based on physical layer, which is a very dumb device, but for small networks we can use. And also a little bit of, I already explained, right, what is because the signal strength tend to diminish. So then we need to give them the boost or amplify or repeat. And then the last mile technologies like ADSL, PSTN, and fiber to home. So definitely we can finish this in the next class. Now, again, let's look at the syllabus because you must keep track of your syllabus. So don't think that syllabus is for teacher. No, syllabus is, of course, syllabus is for teacher also, but you are going for the exam. So you must always refer to the syllabus and keep track what I have done, what I have not done, because examiners set the paper based on the syllabus. Especially this kind of very competitive exams, examiners try to be very strict with the syllabus because otherwise a student might get at undue advantage. So therefore, now let's again go through the syllabus quickly and see whether we have covered some more. And you can even take a, because you can open this PDF file in something like Edge browser or any other PDF reader. Now you can simply highlight it. Right. So remember, we are in topic. We finished the OS. Right. So now we have covered these things. Now look at it. Look at how much we have covered. Okay. How much we have covered. What are the things we haven't covered yet? Right. So this is 6.1. So that is our network. Okay. Signal types, digital versus analog. Properties like amplitude, frequency, wavelength, phase, propagation, speed in media. Okay, that is why we talk about V equal F lambda. Graphically represent digital and analog signals. So you know this is how you represent analog signal. This is how you represent digital signals. If it is binary digital, so you can double check whether you know it or not. If you don't know, so that means something wrong with either your teacher, that teacher is not teaching that, or you have not understood it, right? So you can see what is wrong, right? Solves problems related to relationship between signal properties. So that is why we need something like, that is why I told you that fiber optics is better than copper wire in some cases, because some of those distortions are not affected. And I told you that we need to use repeaters, boosters, because signal strength tend to deteriorate. So we have covered those things. And some of these, again, we will revisit. Then today we discuss about explore the signal transmission media, wired, twisted pair, coaxial, fiber optics, etc. Then unguided media, some properties like noise, attenuation, bandwidth, latency. So latency is again that delay. Latency is another word for delay, right? Delay distortion. Classifies media as guided and unguided. Yes, we classified like that. Describe how latency, bandwidth, noise, attenuation, and distortion affect signals. So again, latency means delay distortion. Okay. So still we have not done topologies because topologies will take separately, right? Then still we have not discussed too much about these things because encoding, decoding, those things we will be we will cover later. Still we have not touched this, but already you know what is frequency, what is phase, and so on, but not we have not formally come to this part. Okay. Right. Still we have not done the switching like circuit switching and packet switching. Still we have not done the topologies, and hubs and so on. So those are the new But we discussed what is local area network, but not now. This is from this point onward, it is network layer. Network layer, and so that is we are moving to the next layer. Logical link layer and network layer. So these are logical link layer concepts. So then we go into the subnetting and so on. That is a network layer concept. Right. So we stop at this point. So take that responsibility, right? And do your studies in a very methodological manner. Okay. Right. So we'll finish the physical layer next time. Okay. We'll stop. Thank you.